Example 1. A sample of 100 eco light bulbs is found to have a mean of 1570. This is the initial population mean. Okay? If the lifetime of all eco bulbs is to have this one is 120, this one is given to be the population standard deviation. We must be very clear, okay? We break the problem down. It is given. Okay? It has a standard deviation, means the lifetime of all light bulbs. All, that means population. That means your whole population is like that. And then you collect a sample of what n equals to 100. Correct? And this standard deviation is the population standard deviation. And it's assumed to have a mean of 1006. Use a 1% level of significance to test whether there's evidence that the mean lifetime has decreased. That means you don't know whether it is still 1006 or less than 1006. So when I conduct my test, I will say this, oh, okay. See, this is step 1, right? Remember? If you refer to just now those step 1, 2, 3, 4, 5. Step 1 is to define. Step 2 is to state your hypothesis. H1, the default statement mu is equals to 1006. Now you have to decide, okay? Is your H1, you want to test whether mu is greater than 1006, less than 1006, or not equals to 1006? You have to make a decision. What do you think? Less, very good. And remember, I told you in a typical exam question, the level of significance will always be given. They want to give a 1% level of significance. Does it make sense to all of us that when H0 is true, by central limit theorem, X bar should follow a normal distribution with 1006, and because this is the population variance, population standard variance divided by 100. All of it? Correct? Now, if this is the distribution of X bar, then you normalize X bar, you will get Z. Follow what I'm saying? Is this given? Yes, right? No, not given. Oh, okay. Sorry, I should have printed for you. Does it make sense? Yes? Okay, now, remember our, let me, here, remember our decision making? Correct? If your p-value is less than this alpha, that means your 1%, then you reject H0, that means it's a rare event. So now our objective is to calculate p-value. And really, how do we calculate p-value? It is the probability of getting this kind of, is this one right? Actually, your 1006. And your observed X bar is 1570. Because just now you saw the question, out of 100 light bulbs, this is your 1570 is your sample mean. That means what happens is I collect 100, x1, x2, x3, x4, with x100, 100 divided by 100, I got 1570. Correct? What is the probability of getting a value as extreme as 1570? That means I want to find out what is this probability. Of course, then you tell me, hey, Mr. Wu, why you so troublesome? This one can calculate already. Just see and calculate. Why you want to do this? Follow? Why you want to do this kind of thing, standardize and all? Agree. I totally agree with you. Stupid, right? Extra, right? Seriously? An exam actually don't need to do all this lah. But I just want to tell you that if you standardize, you will still get the same answer. Whether you do this or do this, you will still get 0.0062. Follow what I'm saying? Yes. Okay, sorry the first few examples a bit more lost, so after that we just carry on doing already, okay? Okay, I want to highlight this one. Not part of solution. Everything I draw here is just to illustrate for the first example. After that, I won't draw anymore. Okay? Can? Now, remember I said there are two test statistics like that. Correct? Now, what happens is this. Beforehand, we decide on our decision-making rule. This is 1%. Level of significance. Correct? Okay, you copy, right? Copy, you copy, Then, if x bar is true, sorry, I forgot to fill this up. 1600, right? If x naught is, h naught is true, the mean is 160. This must be 1600. Then we say, okay, I got my sample mean to be 1570 here, and we found out that this area, was 0.00621, and actually this is the p value. Correct? Then we say, p value, since p value, this one is small compared to 1%, 1% is 0.01, therefore we say, okay, happy, we reject H naught. Correct? Rare event, far away from 1006. There's another way of making the same conclusion. We could have said, okay, if I inverse norm 1%, I could also get this particular critical value, right? You can calculate inverse norm, you will get 1572.08. Another way of getting the same conclusion is this. I inverse norm 0.1%, I get 0.01, I get 1572. If 1570, since 1570 is less than this, it will still end up the rejection region. Follow? Yes? So, I can therefore say that the rejection region is x bar smaller or equals to 1572.08. Can? Now the same thing can happen when I transform the value, transform x bar to z. How? Let's do exactly the same thing. I'm going to quicken my pace now. I can do exactly the same thing and I say 1%. Correct? I can do the same thing, 1%. Now the good thing about using standard normal is, if this is 1%, this value, then we do the same thing, okay? Then we say, okay, when we do this value is 1570 minus 1600 divided by 120 over root 100, which actually will end up with minus 2.5. You end up here. Minus 2.5, sorry. Then this probability we can also calculate, which is not a big problem. This probability we can calculate and realize that this probability, okay, wait, before I tell you answer, what do you think is this probability? It's alright. For sure, right? Same must be the same Otherwise, how to arrive at the same conclusion? This must be the same. 0.00621. Similarly, I can also calculate this inverse norm 0.01. I will get this value. I will get minus 2.3263. Therefore, my rejection region is Z smaller or equals to minus 2.3263. This Mr. really talk so much. I promise you next lesson won't be so loso. We will just make the example. Because I need to set this up. We are very familiar. After that, it will be very easy from this point onwards. If you can really understand example 1, it will be really easy for all of us. So let's continue to answer the question again. Conclusion. Since p-value is this, we say that it's smaller than 0.01, which is the level of significance. We say H0 is rejected at 1% level of significance. It's so rare that we don't think it's quite possible. What did the question say? The question asked, state whether central limit theorem is used. Yes, central limit theorem is used. Why? Look carefully. Of course, I said so already. But look here. Your lifetime of all light bulbs has a standard deviation and mean of 1006. Nowhere is it stated that X, whether X is normally distributed or not. Nowhere in the question. If it is not stated that X is normally distributed, we cannot assume that X is normally distributed. I mean, we have to make use of central limit theorem to say that since n is large, therefore x bar follows normal distribution. Follow? Yes? Remember step 6, previous chapter? So, yes, the central limit theorem is used to conclude. That's that. So far, so good. Yes? Okay. Now, I don't think I want to go to example 2, but I want to say a little bit about the p-value. P-value. Look here. P-value is the probability of obtaining a result as extreme as the observed value. Correct? Let's look at our notes here. Sorry, I want to cover a little bit here. Here. This is page what? Can you tell me? Just before 7.3, there's this diagram here. Page 7 also. Page 7. Okay, let's take a look at page 7. Go back to page 7. I want to talk about this. Very difficult, this idea. Trust me. Remember, for one tail test, it's very easy. For one tail test. One tail test means smaller or equal. Smaller than or bigger than. This is 30. Then we say, 38.2 is observed. This is our p-value. All of us can understand the probability. Can I have attention, please? I know finishing, just give me two more minutes. Finish this idea, we're done. Thank you. P-value, for one tail test, we say, we observe 38.2. The probability of obtaining a value as extreme as 30.2, that's the p-value. The smaller the p-value, the more evidence we have against H0, therefore we reject H0. But what if it's a two-tail test? Now, this is the two-tail test. For a two-tail test, now if I observe, I'm not going to use 38.2. If I observe 35, for example, this is my observe. What do you think will be my p-value? My p-value, remember that when I define p-value is this. The probability of obtaining a value as extreme as the observed value. So when I say extreme for a two-tailed test means not equals to k. That means I could be here or here. When I say extreme, that means this can be extreme, here also can be extreme. Therefore, the p-value is like what is stated here, is the sum of the two areas here and here. That means if you observe it as 35, you get this area, the p-value is this area times 2. Because p-value is the probability of obtaining a value as extreme as the observed value. Don't understand fully is also okay. Just remember first. As we do, it will make sense. Yeah, I just want to mention this first. Okay? Is that alright? Okay, thank you. You've been excellent.